This is the last example for the series of state space lectures and examples. So what we want to do is take a look at this particular state space representation. In fact, it's the same one that we found at the end of example 4, so that way we can check that we get the right answer. Alright, so what we want to do is start by finding Si minus A. Alright, so let's start by finding Si minus A, which is equal to S times the n by n, or in this case 2 by 2 identity matrix, which is 0, 1, 1, 0, 0, 1. And then subtracting from that A, so our A matrix is 0, 1, minus 2, minus 2. And so when I subtract this, what I get is S, and then minus 1, and then 2, and then S plus 2. Alright, next thing I want to do is take the inverse of that. So to do that, all I've got to do is do some switching of locations of some of the entries, and then divide by the determinant. So it's equal to 1 over the determinant of Si minus A times, and then what we do is, of course, we're going to switch the on diagonal. So this is going to be S plus 2, and this is going to be S, and then we're just going to change the sign of the off diagonal. So in this case, it's going to be 1 minus 2. Okay, and then all we need to do is actually calculate this determinant. So the determinant of Si minus A is going to equal to S times S plus 2 minus 1 times 2. So when I multiply that out, I'm going to get S squared plus 2S plus 2. Okay, so then what we want to do is take C times that. So remember, C times Si minus A inverse times B plus D. Alright, so we've done only this part so far, this Si minus A inverse. And so what we're going to come up with then is 2, 1, multiplied by, and then I could just put 1 over S squared plus 2S plus 2 for ease for right now, multiplied by S plus 2, 1, minus 2, S, okay, and then multiplied by 0, 1, which is B, and of course we can add to that 0, which is D. So what we want to do is make sure that we can execute this multiplication. What I might want to do is start with the this part multiplied by B. Okay. The reason for that is that it will make this a little bit easier. So remember, to get the first entry here, what I do is I take S plus 2 multiplied by 0, so that's going to be 0, and then add it to 1 multiplied by 1, so that's going to be 0 plus 1. Okay, and then the next entry I would take minus 2 and multiply it by 0, so I would get 0. Alright, so again, minus 2 multiplied by 0, and then take S and multiply it by 1, which gives me just S. Alright, so then all I need to do is take this 1 over determinant, S squared plus 2S plus 2, and then I have C, which is 2, 1. Alright, so to reduce this, it's going to look like the following: 2, 1 times 1 over s squared plus 2s plus 2 and s over s squared plus 2s plus 2. And so essentially what we're going to have is equal to two times this top part plus 1 times this bottom part. So when I get that, what I'll get is s plus 2 divided by s squared plus 2s plus 2. And we can actually verify this if we go back to example number 4. I'm not going to do it in this video, but we can verify that this is in fact exactly the same transfer function that we started with, which just goes to prove that this is in fact how you get the transfer function back.